All right, tonight's speaker is a very special speaker with quite a long history of data-related experience. He started his career at Oracle, was formerly the VP of Technology at DoubleClick, and he's the co-founding CTO of Ideeli, which he grew from 2 people to 250. Please welcome Mark Uhrmacher.
Thank you. Can everyone hear me in the back? Excellent. Good evening. I am honored to be here and really excited to go through some of this. I like to start my presentations with a quote. And this one has struck me since I was in high school. I studied philosophy. And it totally makes sense given this particular topic.
Just get the mic a little closer to your mouth, please.
How's this?
That's great.
Dearly beloved. So, you cannot step into the same river twice for it's ever flowing. Now this was a description of life itself, however it certainly applies to database technology nowadays. So along those lines, I'm going to tell you a story about, and I'll talk about that sort of narrative format in a second, but about things that started roughly 6 years ago. So some of the statements I'm going to make about the technology options at the time are no longer true. And I guarantee there's somebody in the room who knows more about one of these things than I do, or each of these things, right? So feel free to interrupt me and tell me something, or inform the room when I'm making a mistake, because I'm sure it's going to happen. When I originally built this presentation, I started with a whole bunch of background material, and then I was going to go into case studies, which is a fairly standard presentation format, except it was really boring. Right? Because there was nothing to grab you as you got all the background info. So what I did is I flipped it around. So it goes back and forth. It's the narrative, and then I'm going to make some more generalized observations around the technologies that we evaluated and chose. And it'll be clear when I'm going back and forth. But as I said, I encourage interruption, questions, statements, BS, whatever. You want to take me off topic, let's go for it. Somebody will then try to bring it back in. Maybe it's me, maybe it'll be Eric. But net, I like an interactive presentation, and I particularly like to hear myself speak the whole time. If we make it to the end of my presentation in the allotted time, I will have failed. So, there's one slide of background material, right? I presume for this crowd, I don't need to go over ACID. I would say the CAP theorem is somewhat more novel, and it's really interesting because it's been highly sort of misinterpreted over the last 10 years, I would say, since it was quoted. And in fact, I think Brewer reiterated it in a more precise fashion. But in the end, so the discussion is around consistency, availability, and partition tolerance. A lot of people say you have to pick 2, and it's more of a continuum. And a lot of the choices that we make as practitioners are about applying the particular tools at our disposal to the problems that we see, and hopefully intelligently. The other thing is just a very straightforward thing. You see this pattern throughout computer science and computer architecture at a variety of levels. This is L1 cache. This is what goes on with databases. This is what goes on with RAM systems. There's no such thing as a big, fast memory. It can be big or it can be fast. It cannot be both. Right? And we frequently are playing trade-offs with caching architectures to get the speed of the small memory against the data, sort of data storage or the cardinality of the big one. Does that make sense? So, briefly about the Ideeli business. Now, this is not going to be a long conversation, but in the end, we were basically putting people in a race, right? Limited time, limited availability product targeting women, released every day. So an email would go out, and we had a very, very tight SLA with our email provider to get the emails out to everybody, within a very tight window. But the customer's in a race. Most of those products are being offered for the first time, meaning, the sort of caching architectures, naive caching architectures don't work all that well because the time it takes you to cache load is a problem given the spike I'm about to show you, right? So we go from no traffic, nothing, email goes out, boom. And on top of it, we're creating a Pavlovian response. So some people just check the site. It's turning 11 or turning 12, depending on your class of membership. I'm going to the site right now. So that led to this. That's a regular day. That's not even one of the big days. And so the way I like to describe this is a self-created denial of service attack. Now, an interesting point here, we would make 15% of our daily revenue in 15 minutes every day. So a lot of the standard techniques you'll see from much larger sites involve, test and correct, right? By the time we would go through a test and correct loop, I've blown 10% of the day's revenue, right? This does not make my CEO or merchants happy. Therefore, it's something you don't want to do. And it leads to architectural problems that are typically associated with much larger businesses. We were basically dealing for a very brief period every day, but where we were making a lot of money with traffic levels that rivaled much larger sites, even on our big days approaching Amazon. So this is what we built it on. We used Ruby on Rails, which the way I like to describe this is, had there been anyone else to discuss it with in the company at the time, it would have been controversial. But it was just me, and I managed to convince myself. And it mapped to a couple of biases that I have about how you build technology for startups, build what you need when you need it. I don't particularly like the Lego brick model of the sort of the content management engines like a Drupal and whatnot, where you get the Lego bricks, but if you want a sphere, you're kind of screwed. And what I figured we could do, having built big scalable systems in the past, in one of the beginnings of what is now called AdTech, we could avoid painting ourselves in the corner from a scalability perspective, which turned out to be mostly right. In this case, we were, it's a shared nothing architecture. For those of you who don't know Ruby on Rails, it's very similar to PHP. It's shared nothing. It's process concurrency, and just beats the bejesus out of your database trying to keep, move state around. But even then, and certainly even now, I would say, we've got a lot less deployment experience with the Rails stack. So there's a lot of emergent behavior. It's one of my favorite terms. So now we're going to make a more generalized thing. This is the baseline. I imagine most of the people in the room know a reasonable amount about MySQL. But it's worth articulating a few of these things. There's you favor consistency over availability on a single node basis. Once you go to async replication, right, you're relaxing consistency in order to gain read availability. So you can scale reads quite well, but some of them are going to be stale, right? And your architecture has to deal with that. And you really can't scale writes, right? So in order to scale writes, you have to do sharding. And we'll talk about sharding in another slide, but it gets kind of complicated. One of the interesting notes about sharding is if you have two high cardinality tables that you're sharding against, then you're doing joins in your application. So you're now breaking the database abstraction. The whole nice thing about joins is that you can leave it to the database, but scaling a big, fast memory is hard. Right. So yeah, and interestingly, that if you look at the way, I don't know about the later versions of Rails, although I think they preserved this, the queries it natively generates pull from one table at a time, and they do application level joins. So it leaves you the flexibility in order to do the sharding, but the flip side is you're doing application level joins, which seems kind of crazy sometimes. In eBay, to this day, you're not allowed to join in the database. You do it in the application because, well, eBay, for those of you who don't remember, I've seen the quizzical look on your face. eBay went up and down like a yo-yo in '99. Like, it was ridiculous. So they brought in Maynard Webb, who eventually rose to be the COO of the company. I brought him in to be, CTO, CIO. And he brought a whole crew of people. And that was one of the rules they passed in order to get past the fact that they were basically relying on, at the time, E10000s, which were these massive machines built by Cray that had sold them to Sun. So these things were complicated. They were really painful to run, and they cost a ton of money. They were backing up the Brinks truck for Sun at the time. So, Ruby on Rails is great for rapid dev. But generating HTML costs quite a bit of CPU time. There's no way you're doing it on the fly with the traffic pattern I just described to you. And in fact, so what's going on is, if you think about the Ideeli data structure, you have a shopping event or a sale. It is made up of several products. Each of those products has several colors. Each of those colors has several sizes. It's a big tree, right? Now think of a typical SQL implementation using an object relational mapper. That's a lot of joins, right? So those queries took a long time, and then you've got Rails doing a whole bunch of string manipulation in order to generate HTML. On a good day, that's slow. On a bad day, that's unreasonable. So there's no way you're doing that in line. So very, very quickly, we threw up Memcache and we put it above the HTML generation. If I had to do it all over again, I would look very hard at doing HTTP-based caching of that and leveraging browser caches and things of that nature. But at the time, we were less comfortable with that mechanism than we were with Memcache, and so we went with Memcache, and it worked quite well. So HTML fragments in Memcache, page assembly was mostly pulling individual fragments from the Memcache architecture. But the typical way Memcache is deployed is with TTLs against an entry, right? So what happens when your TTL runs out? Well, the first request says, okay, let's go to the database. And the second request, because the first one's not done, says, okay, let's go to the database. And so does the third, and so does the fourth, and so does the 20th. And by that point, your database is just getting pounded by all these hierarchical queries. And the resulting experience is not good for your customers. So we had to change the semantics. So what we did is we ended up pinning the entries in Memcache with day-long TTLs, and then created a cache warming mechanism, which is a set of application servers that were running in parallel to the ones that users touched. We were just generating the pages to write them to Memcache to keep them fresh. This is for the pages that would change, which is typically around inventory information. Is this speed good? Do I need to slow down? All right. And so here's a picture of the cache warming architecture. Right, so as I said, we're generating, we have a cache warming worker, which is going to a set of cache warming application servers that are not servicing customers. And so this was it's interesting because we effectively put a harness around the website that said, go generate, rather than being slick about generating these entries into the HTML using another mechanism. So, and the client there was running curl. I mean, this was not the most sophisticated thing in the world, but it was bulletproof. It worked really well. Eventually, we got to the point where when we would detect changes in state, i.e. this product sold out, or we got more units, we would push something to a queue saying, hey, I think this page needs to be refreshed. And so that the amount of time it would take, instead of just being time-based, it would also be event-based. Now, we continue to stick with the time-based model as well, of re-evaluating these pages, because it catches all your evils. And this is a pattern I've lived with for a very long time, which is even if you think you've got coverage, logical coverage for all of the situations, still having one monthly, weekly, nightly refresh of everything fixes the problems that might, basically if you're getting clever about the logic, chances are you got something a little bit wrong. Does that make sense? All right. Now you'll notice here that actually it says Riak, and because I borrowed this slide from some other presentation, at this point that was still Memcache. And then this is actually what it does. So this is the latency hiding, right? The green is the latency from the cache warming servers. The purple is the latency that the customers see. So generally a good thing. So this worked well for a little while, and then we started storing too much stuff in Memcache for a single Memcache node, and we were definitely afraid it would disappear. So we started doing sharding, and with a consistent hashing algorithm. And we figured that if we lost an individual Memcache, that it would be okay. Let's talk a little bit about sharding. So the interesting thing about sharding is different databases have varying levels of support. And this is my third bullet here, which is that some of them actually manage it for you. So that way, that's actually quite nice, because then your clients are all observing the same hash keys and basically mapping of data objects to nodes in the shard ring, right? But most of the tools, so basically MySQL and Memcache, they don't support this natively. Lots of people have implemented their own implementation, which they work. I mean, we used it at Ideeli with one of the Ruby Memcache clients. The downside is many of these implementations differ from each other. So let's say you're working in an environment where you're using Ruby and you're talking to Memcache, all goes well, and then you've got some other piece of software that's running Java. Well, there are Java consistent hashing clients that talk to Memcache, but they don't necessarily use the same algorithm as your Ruby one. So now you're now you're reverse engineering the Ruby one that you got to try to figure out how it works to make your Java one work similarly, and it's quite painful. The flip side is you do have, say, Mongo and several of the Dynamo type stores that provided in their own clients so they maintain a consistent mechanism for mapping data objects to nodes. And I put in a note here in terms of bootstrapping, because a lot of the complexity in these systems has to do with when you first spin up the cluster or when you change the size of it. And in fact, that led me later, we'll get to it, but led me to pick Riak over Cassandra, because at the time, downsizing a Cassandra cluster meant you had to restart it, and I was not happy about that. So, we had become too reliant on Memcache. Even though technically we stayed up, when we lost a node, the user experience was so painful because what we didn't realize is the embodied computational time in an individual Memcache node took way too long to regenerate. So, and that, I think the technical term is sucked. So we needed to come up with a different solution. So what was a different solution? We could cut the data even finer, make sure there wasn't so much data on any one Memcache node that we couldn't regenerate it, but it started to seem like a very contrived mechanism with lots and lots of nodes. We'd constantly be dealing with failures. It didn't look like fun. We played with persistent Memcache. This was Membase at the time. But actually, quite interestingly, we didn't realize this when we first started working with them, but they changed the game. They favored consistency over availability. So when we had our first partition, they just shut down, which was undesirable behavior. Right? We didn't care if we were serving stale data. We wanted to serve something, because when we stopped serving something, it all went to the MySQL database and was generating more HTML, which, as we discussed, wasn't good. But at the time, I was reading avidly, and from some of our friends at LinkedIn in particular, and reading a lot about what companies like that were doing, and leveraged it quite well. So let's talk about the Dynamo data store. So unfortunately, Amazon has come up with a product with the name Dynamo, but before they did, it was great, because there was this one paper from Werner Vogels, the CTO of Amazon, and several members of his team, about an internal data store they have called Dynamo. It's really quite cool, and when they published that paper, very much like Google published the MapReduce paper, and then there were open source implementations of it called Hadoop. The Amazon paper, several different groups have basically implemented some or all of the concepts in that paper, and in many ways also have brought in behavior from other data stores. So the three that I've mentioned here are Cassandra, Project Voldemort, which LinkedIn did, and Riak. So it's a key value, for those of you who don't know, key value query model, very much like Memcache. They are masterless. Any one node goes, it doesn't matter which one. It's not like your typical MySQL architecture, right? It's got one write node. That goes, you're scrambling. And we all come up with our various mitigations on how to deal with it, but you're still scrambling. It's just you may scramble a little bit less than the guy who didn't think about it. So the beauty of these, it doesn't matter which node you kick over, you can kick any over and it'll continue to work. Persistent, very important, given how much data we were using this thing for. And then eventually consistent. So that's how they provide that level of availability. The data on some of the nodes is out of sync with others. And it eventually gets there, and actually typically quite quickly, but sometimes not so quickly. Which is exactly, it was interesting, the reason I happen to know that the CTO of that show was Justin is because I know him, I've met him. I was moderating a panel and he was speaking on it, and he pointed out something which I will steal because, as my creative writing teacher said, he said, good writers borrow, great writers steal. So I'm stealing this one. If you get to asynchronous replication, that is an eventually consistent system. There's really no difference in terms of how you think about how you have to write your application. The one thing is, there are several consistency models that are supported in these data stores, but strict consistency is not one of them. If you need a strictly consistent system, you're talking about SQL databases, or maybe some of the document databases. You're not talking about a Dynamo store. But you get massive availability, and read and write. Because since you can write to any one of these things, and they'll eventually figure it out, the read and write bandwidth scales linearly. Okay, I actually say that in the next bullet. It's primary key based, because it's hashing in to the appropriate node. If you're not doing primary keys, now this has changed, but up until fairly recently, if you were not doing primary keys, you were executing MapReduce jobs, so you're basically doing massive table scanning. An efficient table scanning that's happening in parallel, but it's still touching every key. Nowadays, several of these guys, and you can see that under the bottom bullet, several of these tools are now offering secondary indexes, which I think you still end up having to run your query against every node, but once it hits that node, it's fast. And it is worth noting that if you are going to evaluate these data stores, the implementations vary particularly around conflicts. So given this eventually consistent system, and I can write to any node, you and I may write at the same time. If we do, what are the rules for figuring it out? Cassandra, they went with timestamp. Last write wins. Done. Right? Super simple, and I suspect most implementations use that, but there are times when that's just really not the appropriate semantic. What was in the original Dynamo paper, and what I believe both Riak and Voldemort implemented, was vector clocks, which is a mechanism to understand the provenance of the writes and who the common parent was. So you can actually start to build really interesting code on how to deal with those conflicts. Honestly, that could be a talk in and of itself, and I would not be the right person to give it. There's no questions? Nobody's going to break in? All right. Shoot.
At some point, I'd like to hear more about your decision between React and Cassandra, because you highlight the ups and downs of your use case.
You know what? The slide after this one, I think we'll cover that. If not, throw up your hand. We'll talk about it. So yeah, actually, this observation I already made, which is the first one, which is just async replication is eventually consistent. One of the other interesting points is virtually all of the abstractions of the different types of databases, once you start sharding, they break. SQL certainly breaks, joins, stop working. Several of the aggregates in Mongo break. So the thing I like about the Dynamo model is the API changes the same regardless of the size of your cluster. Sorry, the API stays the same regardless of the size of your cluster. Which, if you start building your software that way, it makes life a lot easier because it doesn't. Suddenly, you discover your Instagram. Okay, let's just go. Virtually no one I know who's been through that kind of scalability could actually, if they had tried to plan it ahead of time, they would have been laughed out of the room, including me. If I had said to my board, "Hey, we're going to be here in 2 years," they would have told me to get the hell out. So yeah, and in terms of just observations on who's getting the love, it seems to me Cassandra is getting a huge amount of attention. And Twitter has adopted it, has put in some interesting features. So I would look hard. I think it's pretty much their game to lose from my perspective with regard to an evaluation. You'd start there and then move elsewhere if it doesn't meet their needs.
Depends. If it is Cassandra, it depends what problem you need to solve. Now, all problems can be solved with Cassandra.
Oh, certainly. And I feel the same way about MongoDB.
Every database is solved a specific problem. Now, everything is standard. Depends on what problem you want to solve and what tool you use to solve the problem.
Well, interestingly, so I think the statement is that every database, every one of these tools solves some set of problems well, and others not so well. And understanding the mapping between that tool and your problem. And that's pretty much the takeaway from this talk, by the way, which is like, hey, you know what? I'm using some examples of different problems that we had and what tools we used to solve them. And then it's basically exactly that thought process of, hey, we got this issue. What's out there? Who's solved this before? What did they use? Because a lot of these are what I call engineering problems. They're not theoretically all that hard. The big distributed hash key, this is something in like software computer science, right? It's not conceptually hard, but the actual behavior of systems, when you actually deploy them, that's where you learn, some of the real cases of the application. So we selected Riak. I actually wanted to totally replace Memcache with it. But this is interesting, so this gets exactly to this. Here is some emergent behavior. We had basically built software that was reliant on the sub-millisecond response times of Memcache. And Riak was running at 5 milliseconds. So there'd be keys referred to multiple times through Memcache in the same operation, typically at different levels of the call stack. right? So it wasn't easy to just say, okay, just look it up once and then store it in a variable. It was, you know, this call would look this up, and it would call something else that would look it up again, et cetera, et cetera. So we became very reliant on it, and once we replaced it with Riak, 5 millisecond response times, if you're calling it several times, that starts to make the operation really slow. So we ended up actually creating a multi-level cache with Memcache in front of Riak. Riak provided the persistence, Memcache provided the performance. And that was entirely tactical. It's not something I would have chosen, and if I started all over, I would just say, no Memcache, let's just use the Dynamo store and deal with the performance semantics. But I had a running system and a body of code, and going and rewriting all that stuff to use some sort of, slicker caching layer or something along those lines, sort of process local caching layer, was not in the cards. So actually, this doesn't get at the, this doesn't get at the selection of Riak over Cassandra. There were two things that played into that choice for me. At the time, as I mentioned, when you downsize, actually, changing the size of a Cassandra ring even to this day is an expensive operation. It's less expensive with Riak. Beyond that, at the time, and I think they fixed this, if you downsized the Cassandra ring, you had to restart the cluster. And I didn't know what my cluster sizes needed to be ahead of time. And I didn't want to be stuck at my peak. But I also didn't want cluster downtime if I could avoid it. So once we had it in place, there were a couple applications, a couple features that we built which were much, much easier. Right? Favorites was one of them. But again, we're talking about some of the emergent behavior of the application. We started out, we knew it had the potential to be a high read-write application. We didn't want to centralize all those writes into a single store. So we had already deployed Riak, so it was a fairly straightforward thing to say, hey, let's store it in Riak. But we stored the HTML representation of people's favorites page, which is all well and good, except we had somebody who, I don't know why, just this isn't the first test group. We had a test, I'll talk about the testing system in a little bit, but we were exposing 5% of our users to this feature, and somebody put 1,000 products in, which took some doing. But then it would just end up all kinds of crazy performance issues. We were storing this HTML, we were using a protocol buffer, client, so we were serializing and deserializing these big HTML documents, and it was brutal. So in the end, I don't recall if we ended up changing the client, or we just normalized it. So what we ended up storing against every user was a list of product IDs, and then we had a separate bucket, which is effectively a table in Riak world, of ID to HTML mappings. And that worked out quite well. And I believe that is what's running in production for 100% of the users now. It was long, but I don't remember. I mean, it was 1,000 products by probably, call it 1,000 bytes of HTML. It just ended up being pretty ugly because you're effectively copying it and running some transform on it. But really, what we should have been doing is using the RESTful client with the JSON representation, because then we wouldn't have had to remap the markup. It just would have lived there. But maybe the database does it too, but it had to do it with protocol buffers, I would imagine anyway, unless they were storing protocol buffer information directly in Riak, which I don't know if they do. So, another, in the related products, this is straight out of what LinkedIn did. So we were taking a look at how LinkedIn did people you may know. And our related products is operating very similar. And this design pattern I see all the time now. I'm a consultant now, and I see this one working very, very well, which is you set up a batch job in Hadoop, right? And that's figuring something out. And in the case of LinkedIn, it's people you may know, which is a triangle close problem, right? I know you, I know him. It's going to guess that you two know each other, unless you already are linked, right? So it's a triangle. It's sort of from a graph, it looks like a triangle. It's closing the triangle, the third leg of the triangle. It's a fairly straightforward problem, but of course they have it in massive sizes, so they run a big Hadoop job to do it. The end of the Hadoop job, after it has figured out which users to suggest you may know, writes it back into Project Voldemort. And they're doing it in parallel, so each Hadoop process, it's probably a reduced process, is writing into Voldemort. So taking advantage of all that write bandwidth that the Dynamo type store has, and getting the load done very quickly. Because if you think about when you typically deal with these very large batch jobs, one of the biggest problems is the serialization at the end of the day, right? If you basically have a Hadoop generate a gigantic file, and then pulling that file into a database, once you start doing it at scale, that in and of itself becomes a very painful operation. And they managed to do it all in parallel, and we did the same thing. So in our case, it was Riak, in their case, it's Project Voldemort, but they're very, very similar tools in that regard. And yeah, here we could just experiment with a variety of algorithms before writing these things back, so we can actually even take sets of users and put them in different groups. Sure.
If you do that, and you keep looking for people you may know, the first 15 or 20 appear pretty quickly. But you can keep scrolling, and it'll keep suggesting people. Was that done on the fly, or was that all stored previously?
Up until about a year and a half ago, it was all stored. I think they now are doing something slick, very similar to kind of the queuing structure I was talking about before. I think when you add somebody new, they're doing some quick comparisons between you and that person's, group of people. I think, I'm not 100% sure. It may be that they're just running them, so they're running in batch, but they're running batches every 30 minutes or something like that. I don't know, but it does seem like it's snappier than it used to be. I certainly can find out because I know some of the right people over there. But the net is, the basic structure is batch and write to this big parallel data store, which is, and again, I'm seeing this a lot because a lot of people like to talk about real time. Real time is hard. It's expensive. It is on the 20 part of the Pareto curve. And so you need to make sure you're in a situation where the difference in performance, the difference in latency, is important enough to your business to justify that much mechanism. Very rarely have I seen anyone stand up to that kind of scrutiny and win, other than AdTech and program trading and Wall Street.
What about real-time incrementing? That sometimes seems a little more efficient in some cases.
It's a lot more efficient. It is a good special case, right? And although real-time incrementing and massive scale, that was a very hard problem, which is why Twitter basically has 10 engineers committing on Cassandra. Right? It's fascinating. Though they are using an open source project, they literally have 10 people who's 100% of their job, 10 developers, 100% of their job is committing on Cassandra. They put in the counters, they put in the distributed counters into Cassandra, which was it's a hard problem. I think Redis is very good for centralized counter management at ridiculous speeds. So there was good. Am I good? All right. There's a question back there.
So for that batch Hadoop job, is that your entire user base that it's run against, or is it a selected subset?
That's a good question. So, sorry, to repeat the question, is the parallel Hadoop job running against the entire user base or a subset? And in our case, it was the entire user base because it just wasn't that big, right? It's in the single-digit millions at the time. But in general, we were very constrained on product. So really, you're looking at a matrix, right, of product and people. And the product side, because the flash sale side, we didn't have that many products available at any one time. So that part of the matrix was quite small, meaning that we didn't have to spend a lot of time pruning out people who hadn't been on the site for 2 years. We certainly could have. We just didn't, because it wasn't necessary.
So how can Hadoop, especially in the placement season for Ideeli, 15 minutes interval with your most of the revenue, how do you handle that high pay for the season?
Okay, so the question is, given the sort of latency requirements that I described earlier about the front end, how can Hadoop play here given its notoriously long lead times? And the interesting thing is, we're launching a new sale every day at Ideeli, right? So what we were doing is pre-calculating, based on the past, what products you were likely to like out of the assortment for tomorrow. So there was no real-timeness about it. It was all about, okay, in the past you bought homewares, we've got some homewares coming tomorrow, we're going to suggest homewares, right? It was not, hey, I'm in minute 3 of my 15-minute beat, and I'm going to draw inferences from that. We thought about that, but that was exactly are we going to do so much better using that data that it makes sense to invest in a completely different infrastructure that can handle that kind of speed?
So basically was individualized Hadoop for the pages like
Yeah, so there would be a queue. So it was individualized. There would be a queue in Riak for you. Because actually, one of the nice things about Ideeli was everybody had to log in. So we knew who you were, and we have a queue of product that was part of today's assortment
based on your history.
based on your history.
So, correct me if I'm wrong, but that doesn't include user-based affinity on the recommendations? Other people like you, like bot, because you any data on that people bot at that point? You were in the
So the question is, does it preclude you from using,
like Amazon, other people bot?
yeah, the sort of the collaborative filtering? Yes. Right. And the answer is no, it doesn't preclude you because you can compare people from the past, right? But you can't compare. You can't do product to product affinity.
Okay, let's see what it's doing.
Yeah, because unless you've sold that product before, and roughly the whole point behind flash sales is roughly 60% of the inventory being offered at any given time is fresh. So yeah, product affinity recommendation engines don't work. At least not unless you can run them very, very quickly, but really quickly. Like that would be hard. But people affinity do, and so it's sort of like, well, you like this brand and you like that brand, and there's 10 other brands you guys both like. Well, then I'm going to suggest that same brand to both of you, and that was done. That was part of the model.
But how are you getting to view those recommendations since you have any data on what anyone likes?
So we had plenty of data what people liked in the past.
No, the new products, there's no idea of what you.
So the new products we would make we would take brand and color and sort of category into account as and create a big polynomial against all those things and figure out recommendations. So there's plenty of data, even though you may not have sold this particular jacket before, you sold other jackets like it, and its brand is, people who like this brand tend to like these other 3 brands, so anybody who likes any of those, they're in a cluster.
So, the obvious, this is probably obvious. The reason there's such a stampede is because the consumers are afraid that the products are out.
Exactly. Yeah, it's limited time, limited availability, right? When the time is up, product's gone. When it sells out, product's gone, and nobody knows how much there is. So if think like QVC, you don't know until it counts down the last 3, and then you know. Cool. Feature testing. This is one of my favorite topics. This is more and more I'm realizing that the best web platforms out there, whether it be eBay, Google, Facebook, Amazon, Netflix, they're running thousands of tests right now each. They've so inculcated both their culture and their tool set that they can actually have individual product managers go, hey, I have an idea. Throw something out there, throw a reasonable chunk of traffic at it, and see if the idea works. So, we decided we needed something like this at Ideeli, and we actually built it, and we built it using Riak as the backing store, because this is exactly what it's meant for: high read bandwidth, high write bandwidth applications, where we could write back, and persistence, so we could tell, you're a member of this test group, so you know what, I can't run, you're now biased, I can't run test B against you because you were in test A. So persistent over a long period of time. And it was super interesting, some of the stuff that you would learn, and I'm sure we've all gotten that. The early phase of a startup is all about intuition, and all about, like, here I understand what the customer needs. Frequently people come from the domain that they're trying to service. I was in an ad agency, I'm not really tools for ad agencies or whatever. But you get to this point in the life of a company where your distance from that is high, right? You no longer know the customer all that well. And the best companies move from being intuitive-based to being data-based in terms of figuring these things out. And it's amazing once you can actually run, like Google famously tested the shade of blue on their links to see which one got people to click the most. That may be a little extreme, but net-net, the value of being able to run these types of tests regularly is high, and so it has to be built into the actual content delivery framework. There are a few people who build tools that do simple things like change the color of the button, but if you want to test whole flows or messaging, etc., it's got to be built into your content environment. So we did that, and we did it using Riak, and it was again, you didn't have to worry about the data store being overwhelmed, so implementing the feature was just much, much faster. And you could actually pull the test results in the middle of the test using a MapReduce job against the React nodes if you wanted.
Actually, I've been told that it's hard to get a true random sample from a distributed database. I was at a Couchbase talk last week where that's something that is still working on. Actually, really randomize across all these different custom nodes, distributed random. Is that right?
We didn't use the database for randomization. That we left that in our app. So the app would make a decision. If there's no record for you against this test, it would make a decision as whether or not you were in test, control, or other. And then from there, you were always in that group forever, right?
So if you wanted 1% test, everybody who came in, there's a 1% probability.
Roughly, right? It's pseudo-random, so roughly. There's probably some binary errors in there, or quantization errors, I guess would be the accurate term.
So experience, whether it's random or not, it may in terms of grant number, it's product testing.
I think
it's not.
Yeah, I think when you want, and I'm no expert on statistical significance, to be honest, right? But when you are evaluating a feature's effect, you want to make sure you don't have a biased sample. So one way to do that is to randomize, and it may be that your feature is only targeted at certain people, like, okay, this feature is targeted at people who live in the Sun Belt, so you want both your test and control to be selecting people from the Sun Belt, but within that group, you still want to randomly select, so you're not creating some notion of bias. Like, if you do it temporally, let's say, only people that, everyone who shows up at night is going to get, option A, and everyone who shows up during the day is going to get option B. There is a chance of bias in there because there may be some other contributory factor why people, are logging in at night, like they don't have internet for or something like that. Does that make sense? So this is where I end the narrative format. There are other data stores that are skipped. There's actually a very well-known one that's already been discussed today, and that's our friends at Mongo. Unfortunately, and I have a lot of respect for the guys at formerly 10gen, now Mongo. The founders, I used to work with them. But that being said, I see this tool misused often. And I think it's got what I call the bee's knees problem. It is the bee's knees, and lots of people want to play with it, and so they deploy it without thinking through. Because my guest here pointed out, is this the tool that solves a problem that I have? I went to a company, and they proudly showed me their 48-node Mongo cluster. And I said, there's two things here. One, I think you're misusing the tool. Two, I know your tech ops people are not in the engineering group, which was true. Yeah, it was all on RAM, actually, on top of it. They had, in order to get the performance, they had to put everything in RAM. So it's so now it's a big document structure of Memcache. But that being said, what they were basically had turned it into a Dynamo type store without meaning to. And in fact, when I suggested, hey, did you look at any of the Dynamo stores, they looked at me funny, they mentioned something that had never been uttered there before. In their particular case, it was primary key only. They weren't using any sub-documents. They weren't using any secondary indexing. And they really, really, really were performance-based because they were doing something similar to ad serving that they were doing with SMS networks. So it just seemed like it was very, very poorly selected in that particular instance, and I'm seeing this happen a lot. That being said, I think there's some problems for which Mongo is very well suited. So actually, just briefly through this slide, for those of you who don't know it, it's a document structured database. It's got a very, very rich data model. You can have sub-documents. The sub-documents can have sets and lists and all kinds of very cool data structures, which make your developers really happy because they do not have to spend lots of time thinking about the mapping between the data structure that they like to think in and what's persisting on disk. So it means faster cycle times on development. It means new features are quicker. In fact, I like to put it, it's basically the Ruby on Rails of the database world, right? You can do things very quickly, but you can get in trouble. It's memory mapped. You can trade off durability and performance, and that's sometimes something that people point out negatively about these guys. I think it's phenomenal for hierarchical data sets. So think a patient record, right? It's always query from the top, and you keep on adding things to it, and you never take anything out. You just keep adding the document. Doing that in a relational database sucks. It's just all disjoint. So it's a big hierarchical data model. The hierarchical data model I was talking about would have mapped well into MongoDB. And as an aside, I think somebody is going to figure out how to create the sort of the content part of an e-commerce engine atop Mongo, because it's so much better of a model than an EAV model, an entity attribute value. I don't know if any of you have ever seen the Magento schema, but it will make your eyes bleed. It takes about, I understand, it's on average 180 days to get proficient in writing queries against it. It's just that complicated. And if you think about the generalized problem of, I'm going to sell products, those products have a variety of variables upon which they vary, right? So if it's trousers, it's inseam and waist size. If it's shoes, it's shoe size. You know, if it's auto parts, it could be, you know, make and model. And you just have no idea. So in order to create a generalized schema for that, it's like, I think, what they call fifth level form. It's ugly. So I think the schema list model of a Mongo lends itself to that very, very well.
That's content management and asset management. It's good for that.
Yeah, I can't speak to the asset management because I've never even looked at the
Design that
stages.
uses that kind of one table describes another table.
Mm.
So one table describes the fields you have in another table because you have custom metadata that you can assign to an asset.
It's interesting. That bears more thought than I'm capable of doing it behind the podium. But that's an interesting idea. I mean, I think in general, I'm saying there are certain situations for which it is very well suited. But as a result of its developer friendliness and the sharding model, as I put it here, is deceptively simple, right? It gets really, really complicated when you get up to scale. And I've seen this now a couple times talking to clients and friends, where once they actually start throwing load and needing to shard out, it gets ugly. And it's new. I mean, part of it is it's a very new technology. MySQL at the same age was equally painful to work with. It's just that we now have, you know, a decade more experience with that engine than we do with MongoDB. And you know, as put it here, actually, yeah. So sorry, there's a reference in there I should have removed for my last presentation. But there are a couple threads in the New York CTO Club mailing list about the emergent behavior of Mongo when you start throwing real load at it. Redis, one of my personal favorites. Full Memcache protocol, composable atomic operations. It's a data structure server, so beyond Memcache, the key value is just string and string. You got sets, you got hashes, you got counters. And they're blazingly fast. It does pipelining, I think Memcache does now too. It's got its own built-in publish subscribe, so if you're doing any WebSockets work, really kind of handy. Got a couple of different persistence models, but net, it's lagging persistence, right? It is not, I think it's conceivable to make it a very conservative data store where every time you write, it writes to disk, but basically it becomes performance-wise useless. So mostly you're consolidating your writes, you're basically writing into RAM, and I think it just blits out the RAM to disk is the native model, and there are a couple other models you can use. They tried, actually, it's interesting, they tried to do virtual memory and gave up. It was just too hard. So it's really an in-memory data store, and that's that. There is something called Redis cluster. It's been in development for at least 2 years, and I don't see any signs of it coming out. So I suspect it's another one of those complex projects which may or may not make it. And I have a huge amount of respect for the guys who work on this tool. Like there's one guy in Tires who is just brilliant. Yeah, and then you have to shard it if you want to scale, right? You actually want to scale it all into your memory size beyond 800. And then this is my final slide. So here's some of the things I see happening, you know, coming down the pike. And what's interesting is I see the Dynamo data stores, I see richer data models, right? So people are beyond I've got a blob and a key, and I can put that blob in, I can take the blob back out. You're now starting to get semantic understanding of the data that you're storing. It creeped in there with MapReduce on these things because the MapReduce jobs have to be able to understand the data that's in the documents. I'm now seeing this more and more. You know, it seems to be emerging, and you know, we'll see how it rolls out. It seems to me Couchbase is basically taking the document model but using a Dynamo distribution framework atop it, and Aerospike is doing, I would say more like Redis, but with the Dynamo distribution, and they're SSD only. So blazingly fast. A lot of work in the AdTech world. Hence the optimization point there, which is that there is actually right now a lot of room to improve performance on SSDs, because though SSDs improve the performance of systems built to work on disk, the reality of it is that's only a fraction of what they could do if you actually built a system to work on SSDs. But that's true about your platters as well, right? Like if the drive peg hits the platter, there's nothing you do about that either, right? So net, you have to build resilient systems with redundancy in your storage, but virtually all these systems actually have one model for that or another. So there are other hands up.
Hang on, before we move on to Q&A, first I want to give a great big thank you to Mark Uhrmacher. Okay, what was the hand that was up? Where was that? Now you got bashful. Oh, what's the next question? Oh, there.
How did you guys track the inventory in 50 minutes?
We used this exotic database called MySQL. Actually, we did it. It was pretty intense. That's actually one spot I got involved with personally, and we got the query down to a single transactional query that would allocate inventory. But one of the key thing we did is we represented every unit in inventory as its own row to get around locking problems. Because having lots and lots of contention for an individual lock in MySQL is very unpleasant.
Next question. Yes.
You mentioned using WebSockets with Redis. I'm curious about the load balancing issues around that, if you have something to suggest.
To be candid, I don't have production experience. So the question was about WebSockets and Redis and load balancing. I don't have production experience enough to be able to speak intelligently about the topic. I can tell you that when I looked at it, at the design level, we needed some way to get the information back to the appropriate user. Once the user is connected, you want to be able to send them the right thing. Like, okay, this is the thing you were looking for. Here's your email, not some random person's, right? So that's where I think the publish-subscribe model can work quite well, but I didn't get to the load balancing.
Next question. Yes.
Did you use the built-in MapReduce in React that they were running the JavaScript or
We did use, so the question was, did we use the built-in MapReduce in React in Erlang or JavaScript? I believe we used JavaScript, and we did use it to get interim test results from the testing system. But in general, like the big MapReduce jobs were running in Hadoop, but they were running over log data. They were running data outside of what was in React. React was where we would store it, the results of the computation of what products are we going to suggest to you tomorrow. But the input to that was coming from a different system.
Yes.
Can you just talk a little more about analyzing the results from those experiments?
Okay, so the question was, can I talk a little bit more about the analysis of the results of those experiments? And I get to a level, but I had a team, and one of the team was really, really good at stats, which would not be me. I'm not going to be able to get into a statistical discussion. What I can tell you is the meetings where we show up with data were much more productive than those that were not. That did not have data. Right? Everybody has an opinion. If you show up with numbers, you control the conversation. There were several instances where people's intuition was just dead wrong, and we could actually say, okay, hey, look, this didn't help. I remember actually the quick look feature is one of those ones I didn't really want to implement it. My CEO counted at the table. The quick look is where you mouse over the product and it pops up, from the grid, and people can buy it right there rather than clicking into the product page. Zero impact on conversion. Didn't hurt anything, but didn't help. So it's like I just spent all this time and software development time to build a feature that did nothing.
Yes.
Can you provide more insight into when you would choose SQL versus NoSQL, React versus Cassandra? Because you just said you don't like Cassandra because it's very expensive to scale up or scale down. But what other things can you look at? Do you measure? Yeah.
Okay, so the question was, how do you evaluate these various data stores and select one or the other for particular types of problems? I think that's a generalized version of what you're asking.
Yeah.
Is that fair? And to some extent, think first is to do enough research into the various tools to understand what the inflection points are. In the case of the Dynamo type stores, I think a lot of it had to do with the startup, resize, and shutdown. Shutdown kind of interesting, startup and resize, and then how they behaved in those situations. Plus, when you have conflicts. And so, I guess there's the high level of which of these data stores do I want to look at? And a lot of the time I come at those, it's mostly from the, all right, who solved a problem similar to the one I have? All right, and what do they use? Now that I've got the class of tools, let me see if I think their implementation makes sense. Let me see if they think their implementation makes sense, because usually you can find somebody. I mean, the nice thing with the tech community is you get somebody on the phone, and at this point I've been in this business for long enough that I probably know somebody who knows somebody, right? So you get somebody on the phone, you're like, does it work well? Would you do it again? And sometimes, you usually get an honest answer, yes or no, this is what happened. We really wish we'd stuck with Oracle or whatever it is, right? And then in that you get to the point where you zoom in. So you're starting up a pie and you zoom in, like, okay, now we take a look at this type of solution. What are the ins and outs of it? But a lot of it, from my perspective, it comes from first principles research. You start reading. Most of these things, because they're open source projects, their implementation details are meticulously written up and discussed and debated. And you can see which ones, when you start reading a news group, you can start to see which ones actually are causing people real stress. So that's how I do it. Does that make sense?
Were you putting your logs into these same databases, or were log events stored in a different?
Logs went to S3, and I used Elastic MapReduce to process those, and in fact actually used technology from a company called Qbol to manage EMR, and that's a pretty cool tool. I like those guys.
Next question. Yeah.
Last time we worked for, we have a 30 million user website, and we tried using Riak to do some caching, and it just didn't work at scale. We just constantly saw it crashing. What issues have you seen with it? You seem to be very gung-ho for it.
Well, I go back to my Heraclitus quote of that was then and this is now, and it may or may not be the right tool for anybody. To be honest with you, right? It worked really well for us. We did see the 5 millisecond response times, which was challenging for us with this Memcache thing that I brought up. I'm trying to think. I mean, it was a little rocky at first in terms of getting it started, and then getting the multi-data center stuff to work was also kind of a pain. But nothing that I wouldn't have expected with 2 or 3 year old data store.
How many nodes and general writes per second? How much did you have to store?
To be honest with you, I don't remember. It wasn't a lot of nodes. I think in the 6 or 7. And sort of that's what I remember off the top of my head. And then I never saw any stats on writes per second. Also, bear in mind, with the type of access pattern we would get, there's only a few minutes a day that matter. So averages, and most of the tools will report averages. Average case analysis is another talk, by the way. Average case analysis is almost always an error when you're trying to deal with performance issues.
Yes, in the back.
So based on what you were saying before about React, were you able to add a node to a cluster or take one out without stopping the system or restarting or any? There was no impact?
There was not enough impact to notice. So I'm sure there was impact. I mean,
I'm just but
yes, we successfully changed the size of the cluster without adversely impacting performance. We never did it during the middle of our peak. That would have just been crazy.
Okay, next question. Time for one more.
Might be loaded. So you said you like emergent behaviors.
I like the term. I don't particularly like the behaviors.
Yeah. So basically, what I'm trying to say is when you reach the peak limit of some system, how can you gracefully be breaking that? Because is there some database that can handle it better than the other? You ever looked at that as a consideration?
So the interesting question.
Yeah.
So let me see if I can rephrase this question to make sure that the group heard it. Which is that have I experienced a database that can get to very high levels of utilization and recover gracefully? And
It happens.
oh yeah, no, I've certainly gotten the database to 100% utilization. That is usually quite bad. I mean, if the you know, like not having to bounce it, yes, I've experienced that with MySQL, right? Where you actually you reduce the load and it comes back down. Most people do not tune their systems well for this problem. So what I've found, and so you have the unfortunate issue of talking to a guy who's studied theory. What I have found across my career is most people do not set up to deal with the 100% utilization problem. So they end up queuing all the requests. So what happens when you finally clear the logjam? You get like 3 hours worth of requests queued up to process. I see this a lot with websites. They don't configure their load balancers appropriately, and so this thing stores as much as they can. And then you got to wait for the queue to drain because you're not making changes on the fly at that point, and it's pretty ugly. I think that if you get it right, and I have done this with load balancers at the top end of a website, if you get it right, you can recover quite quickly. But very rarely people spend the time to do it because usually by the time you figure out you need to do it, you're screwed.
First off, thank you, great big thank you to Mark Uhrmacher, full-time CTO of Ideeli. Mark will be here for one-on-one questions. Feel free to come up, and thank you all for coming.